Hello and welcome to Physics Uncomplicated. In today's session, let's understand instantaneous velocity. Consider a ball being thrown as seen in the video. It rolls down the park with a certain velocity. To visualize better, let's plot a graph of this action. The graph clearly indicates the peaks and valleys of the ball's path. If we were to trace the path of the ball on the screen, then this is how it would look. Before we understand what instantaneous velocity is, let's try and understand what velocity actually means. Velocity is given by the formula displacement over time. But what does this actually mean? Come, let's try to understand in this example. From our football example, the initial and final position of the ball can be visualized as seen in the picture. Let the initial position be denoted by 0, 0 and the final position by 10, -7. This indicates that between the initial position to the final position, the ball has traveled 10 units in x direction and 7 units in the negative y direction, that is downwards. The overall displacement is given by the formula that you see on the screen, which is nothing but the square of the distance moved in x direction plus the square of the distance moved in y direction. And the square root of this gives us the overall displacement. If we assume that it takes about 10 seconds for the ball to reach its final position from the initial, then the average velocity is given by the formula that you see on the screen, which equates to about 1.2 meters per second. But during this journey of the ball from initial to final position, the velocity will not remain a constant of 1.2 meters per second. Ball's velocity keeps changing continuously as it is subjected to various other forces like gravity, drag, and lift. So if we need to find instantaneous velocity of a ball at a specific point in time, we need to employ a different approach. The arrow mark indicates the direction of the ball at a specific point in time during its journey. As velocity is a vector quantity, the direction of the arrow has a significant meaning in calculating the instantaneous velocity. If we refine this picture into a smooth graph, then the overall path of travel looks like this, where we have divided these 17 points in time to hundreds of smaller units. But to simplify the understanding of instantaneous velocity, let's go back to this picture. Now, if we were asked to find out the velocity of the ball when it was at position 8, then this is how we would approach. To find the instantaneous velocity at 8th position, all we need to do is go back in time and find out the behavior of the ball when it was at number 8. As simple as that. As we do not have a time machine, let's take help from our high school geometry. In geometry, the slope of a tangent tells us how the behavior of an object with respect to one axis is influenced by the other. So in our case, drawing a tangent to the curve when the ball was in 8th position gives us the exact change of displacement which happened at that instance in time. In other words, the instantaneous velocity.